Alright, hopefully we finish up on this video right here. We'll try to get right to it. So let's do this number 16. I'm going to do this right here. Let me just rewrite it. Makes it easier to show the steps. So it's 1.84 to the x over 3 equals 350. Where do we even start? Well, we start like we did on that other problem. I think it was the last problem we did. This 175, let's get rid of it. How do we do that? We divide it. 175. Now, if you do this in your calculator, it comes out to 2. So let's write it 1.84, let's make that dot a little bit bigger, to the x over 3 power equals 2. Now you could look at this and you say, well, maybe I need to change it to logarithmic form, la la la, I don't know. Well, let's do this. Let's first of all, let's get rid of this 3 right here. It just makes, I think it'll make it a little easier. You don't have a fractional exponent, and you can do that very easily by taking everything on this side to the third power. See what happens? It just multiplies together. Remember the rule for exponents, they just go together. We took this to the third. We didn't really multiply by 3, we took it to the third power, so you have to do the same thing over here. Take that to the third power. Let's see what we get. We get 1.84 to the x power. That looks a lot better than to the x over 3 equals 8. Now we can worry about the logarithms. Let's do that now. This is an exponential form. Remember we had a problem earlier, it was in logarithmic form, and we changed it to exponential. This time we're going to go the other way. So let's do this. It's going to be log base. What's your base? It's 1.84, so we make it little and we put it down here. Log base 1.84 to the 8th power. Remember this is a, log base 4 of 8, I'm sorry, not to the 8th power. Let's say that again. It's log base 1.84 of 8 equals the exponent. Remember, logarithms are exponents. That's what it is. The exponent equals all that stuff right here. We had a problem earlier where we had to figure something like this out. Use the change of base theorem or rule, whatever they call it. So let's do that. It's going to be, so x is equal to, now we don't have base 1.84 in our calculator, so what we do is we go log, or you can do natural log if you want to, of 8, this is common log of 8 over log, or common log base 10 of 1.84. Alright, let me throw that in a calculator, see what. Okay, there it is. Just look to see what I did on the calculator, and it's 3.410. I don't believe, let me see. Yeah, it says if necessary, round these to the thousandths. The whole thing is true, so third place, 3.410. 3.410. People say, well, if that's a 0, I don't really need it. Well, we do. If we're going to round it to the thousandths place, keep the 0 there, and move on to the next one. Alright, let's do 17. I got rid of 16. I need the room for this one. So this one didn't copy so well. I just scanned it from the test. So this, I'll just rewrite it. It's 9 to the 8x. There should be a minus there. It doesn't look like there is, but it's 0.71. Alright, there's no way to get the bases to be the same here. So in order to do something with our exponents, we're kind of stuck, so we use logarithms. So we're going to take the log of both sides. So we're going to take the log of 4 to the x plus 6 equals log of 9 to the 8x minus 0.71 power. Now we have rules for this. First thing we're going to do is use that power rule. Put that over here, take this, and put that out in front. Let's see what we get here. So I've got x plus 6. Since I'm multiplying it, I always take a sum and put it in parentheses. So it's log 4 equals, do the same thing here, parentheses, 8x minus 0.71 log 9. What are we trying to do? We're trying to solve for x. So I want to get x by itself. I guess there's a couple ways you could do this. Some people have done this in different ways. This is how I would do it, okay? I mean, that's how I'm going to show you. So what I would do is I would take this log 4 and distribute it through both of these. Do the same thing with the log 9. In the interest of time, I'm going to pause and just do it. Okay, there's the distributive property. It's x log 4 plus 6 log 4, and it's 8x log 9 minus 0.71 log 9. Now what we need to do is get the x's on the same side. So, normally we like to put the x on the left side. You don't have to, but some people like to do that all the time. So we'll stick with that. Let's put the x over here on the left-hand side. So we have to get rid of this whole thing because all of that is being multiplied by this x, so we have to get rid of the whole term, and we do that by subtracting. So I'm going to subtract this from both sides, and look at this number right here. This number right here, I want to put over on the right side, because I want the x's on the same side, and I want all the regular numbers, if you want to call them that, on the right side. So let's just move this over, we're good to go. Okay, I just did that real quick here. Subtracted 8x log 9, subtracted 6 log 4. Now what do we want to do? I got an x here and an x here. I don't want two x's. So let's swing this up here. And I want just one x. So x is in common, greatest common factor. Let's factor out an x. So I'm going to factor out an x and see what's left over. Okay, that step wasn't too hard. I just factored out an x and figure out what was left after I factored it out. See, took an x out of this, took an x out of this, and I just have log 4 minus 8 log 9 left over. I didn't really do anything to that right side at all. Now what I'm trying to do is get x by itself. Well, what is this parentheses doing to the x? It's multiplying. So how do we get rid of something that's being multiplied? We divide. And I'll just write that out right here. So we get log 4. We divide it by log 4 minus 8 log 9. Now this, we're not going to write this as our final answer. We need to simplify it, and we simplify it by chucking it in a calculator. So we're going to put all that into a calculator and see what we get. Okay, just to save time, I plugged it in the calculator. There it is. I put a parentheses. Now watch what I do. Let's get rid of the calculator for a second and just make this a color. What I did is I put a parentheses here and I put a parentheses here. And then after I hit divide, I put one myself. It doesn't show up. I believe you have to put one right here for it to work, and then put one right here. Now, before the log, it'll automatically put one, so you make sure you close that. So you're going to have a lot of parentheses here. That's going to be in one, that's going to be in one, that's going to be in one. So all those things in red right there, make sure that you do that. Practice, practice, practice until you get it. Let's take a look at it. There it is. All right, you can pause it and look at it to see exactly what I did, and round it to the nearest thousandth, 0.610. 0.610. That would be the answer. Alright, we're almost finished. Let's do this. 18. Now, this doesn't look good. The scanning was pretty bad. That's supposed to be an equals right there. I just rewrote it. So let's do this. Can't really do anything to this side just yet. Over here we have to realize this rule. When you have two logs and you have addition, you use the product rule. The product rule says you just have one log and you multiply these two things together, these two arguments. So it's going to be multiplied 2 times x plus 4. Watch how easy this is now. Both logs cancel out. We have rules for that. You can look back on the previous lessons. Equals 2x plus 8. Subtract a 2x, which is 3x, equals 8. Divide by 3. X equals 8/3. Just keep it like that. No reason to change it to a decimal. That was simple. If you knew this rule right here, the product rule, make sure you go back and review that if you don't remember it. Alright, here we go. Next to last one. This one's a little tricky, but we did this in class the other day. I remember doing it. I don't know if I recorded it. I don't think I did. We just did this to answer one of the questions on one of the worksheets. Let's see what's going on here. This thing right here, it's only the x is being squared. This one, everything is being squared. So if you think about it, it's kind of like this. It's kind of like, well, let me hold on a second. Okay, let's take a look at this. This now, what I did is I take this squared and put it out front. This looks very similar to something like this. Forget the log 4. Let's just pretend it was just 2x. It would look like something like this. 2x equals x squared. Now, how in the world would you solve for this? Well, you'd make it into a quadratic. You'd go x squared, put the 2x on the other side, minus 2x, and set it equal to 0. Now again, this is just a simplified version of this. We're going to do the same thing as we did right here. Factor out an x, set both sides or both things equal to 0. So x equals 0 and x minus 2 equals 0. That means x equals 2. So that's how you would do something like this. This works the same type of way, except you got that log base 4 in there. So watch, this is going to be log base 4 of x squared. I'm going to subtract this on the other side, minus 2 log base 4 of x, set it equal to 0. Now we can factor out. Look, this is log base 4 of x times log base 4 of x. It's got 2 of them in there. So I can just factor one of them out. What are you left with if you factor one of these out of this? You're left with another log base 4 of x. Minus, now look, you got one here too. Let's factor it out of this. So what are you left with? A minus 2 equals 0. Set them both equal to 0. Log base 4 of x equals 0, and log base 4 of x minus 2 equals 0. We just equal it to 2. Watch this. 4 to the 0 equals x. Change it from logarithmic to exponential, so x is 1. Do this. 4 to the second equals x, so x equals 16. That's how you get those two answers. Try to look at this and figure out what we did right here, and then see how it fits with this. Well, we're going to have to go on to one more video. I was hoping to get it done, but I'm running out of time. So we'll do one more video for number 20. Alright, I decided to squeeze this in here. I just did it for you right here. 4 to the first equals this. Then you do it one more time. You see it. I'm running out of time. There's your test.